Okay, guys. Now, this first thing, today we're talking about the distributive property, and this is an extremely important thing. I mean, you're going to be using distributive forever and ever. Distributing is a type of multiplication. So whenever we say use the distributive property, it's saying multiply. So when we're simplifying with PEMDAS, we're always going to be multiplying. So whenever you see something that needs to be distributed, we should do that before we do any adding, because distributing is multiplying. All right, but let's look at a couple of terms here quickly. The first thing we're looking at, it says equivalent numerical expressions. Numerical expressions that may look different but represent the same value. Okay, so 4.5, that's 9, and 3 squared, that's 9. These two things are equivalent numerical expressions because they're numbers. All right. Okay, now taking that same idea, equivalent variable expressions, those are variable expressions, so it's expressions that have variables in it, x, y, t, okay, that may look different but represent the same value. Okay, so if I look at this first one, 8 times the quantity x plus 2, right? Do you see how that's 8 times the stuff that's inside there? Okay, and 8x, whoa, why don't I do that? 8x plus 8 times 2 are equivalent variable expressions. They look different, but they represent the same the same amount. Okay? All right. Now, let's look at this first example. It says, you and a friend are going on a camping trip. You each buy a backpack that cost $90 and a sleeping bag that cost $60. What is the total cost of camping equipment? Now let me ask you something. Liam, how would you figure this problem out? What would you do?
I would do 90 times 2 and then 60 times 2 and then add them together.
Okay, so Liam says he would multiply both of these things by 2, right? Because there were 2 people and they each bought the same stuff, and then he just add that together. That's one way of doing it, right? 90 times 2, 60 times 2, put it together. All right. Zach, what would you do?
I would add the 2 and then multiply.
So now Zach says, you know what? I'd add 90 and 60 and figure out what that is, because that's the price for one person. Then I'd just multiply by 2. That'd be the price for everybody. Okay? Now, that's the way I would do this one, Zach. But I'm going to do it the way that Liam said first, because it's a good example of the distributive property. All right, so let me show you. Both of these folks spend $90 and $60, right? That's how much one person spends. But there are 2 of them. Okay, so I'm going to need to multiply that amount by 2. Now, guys, we can probably do this in our head. Justin, what's the quantity that's inside the parentheses? It's 150, right? And then when I multiply that by 2, what do I get, Fritz? When I'm we did that already. You'd get 300 total. All right, but here's something that I want to show you.